Hey everyone, so welcome. We are into compound interest. We're going to talk a little bit about compound interest today in Hrs Algebra 2. We are live period 3. We're also going to talk a little bit about solving. So if you are curious as to how something happens, please feel free to ask a question. Otherwise, at the very end, I'll give time for questions as well. So the first thing that we're going to talk about mainly is money and how to get more of it, which I'm sure that everybody kind of will enjoy. Compound interest is a way for different banks at some points to give you interest or money back. The way that they do it is not necessarily how we're going to start, but I want to show you the kind of behind the scenes as to how this occurs or how it happens. The first thing that you have to know is this formula that you're using has different parts to it. A is the amount, P is your principal, R is your interest rate, N is the number of compounding periods per year, and T is the number of years. I'm going to rewrite that up top here, just so we have it. Now, generally speaking, the more you compound something, the more money you'll receive. As you'll see here in this example, you can use your graphing calculator for this or any type of calculator that you have. But we'll take a look at example number 3. So it says find the final amount of a $500 investment after 8 years at a 7% interest, compounded annually, quarterly, monthly, and daily. So really it's asking us for 4 different equations, kind of similar to the previous examples that we've had in class where they ask us for multiple things. This one is also asking us for multiple compounds. So first off, I'm going to note what my P, R, N, and T are because that's what I usually need in order to find my A. P is your principal. That's your initial investment. So in this case, it's going to be the $500. T is your time. It just kind of stands through here. Just looking 8 years. So T is going to be your 8. 7% interest. That's your rate. R for rate. So we're going to move the decimal 2 places at 0.07 for our R value. And then our N value is what's going to change for each of these types of problems. So annual, N is going to be 1. Quarterly, N is going to be 4. Monthly, N is going to be 12. And daily, N is going to be 365. Yeah. So to kind of recap here, we're trying to find out what our amount, our A value is. So we have to find each of these individually. P is 500. T is your time, so that it says 8 years. R is your rate, so 0.07, since we want to use the decimal for the 7%. And then the N is what's going to change. That's the number of times that you compound. Annually is 1. Quarterly is 4. Monthly is 12. And then daily is 365. So I'm going to show you how to set up example A for annual. And then after that, I'm going to show you you only need to change your N value, and you're going to be able to solve for all the problems. So in letter A, we're going to use A is equal to our principal, our P, 500, times 1 plus 0.07 over our annual, so 1, to the 1 times our T, which is 8. So we'll go ahead and we'll plug that into our calculator. And you'll end up, since this is money, we'll round to the penny, $859.09. That's pretty much it. The only thing that's going to change is the N value. So when you do letter B, it's going to be A is equal to 500 times 1 plus 0.07. Since it's quarterly now, it's divided by 4, and then 4 times 8. and I'm getting an answer of $871 and rounded up 11 cents. So if you're plugging this into your calculator for the first time, I like to do this in steps. It's totally up to you how you want to do this, but I usually do 0.07 divided by 4, enter, plus 1, enter, to the 32nd power, or 4 times 8, enter, and then times 500, enter. And that should give you your answer. Some of you have the really nice calculators. You can do it all in one thing. Just note that if you do it all in one, I would recommend putting parentheses around 0.07 divided by 4. So you would have 2 sets of parentheses in that setting. Go ahead and move it on to monthly. So C, A is equal to 500 times 1 plus 0.07 divided by 12. So 12 times 8. So 0.07. Again, if I was doing this in my calculator and I had like just a normal scientific calculator, I'd do 0.07 divided by 12, enter, plus 1, enter, to the 12 times 8 power, enter, times 500, enter. $873.91. And then our last one, which is daily. So 0.07 divided by 365 plus 1 to the 365 times 8th power times 500. And you'll notice that it's not like you're getting a ton of money whenever you're compounding, the difference between the compounds, but you are continually increasing. 2.9. Sorry, 2.9 if I round. You are increasing each time. That's exactly what you want whenever you compound. The more you compound, the more money, essentially, you're exponentially gaining. Now, a lot of different investments don't usually compound once a year or 4 times a year or even daily. They do it something called continuously. So if you go to your next set of notes, we're going to talk a little bit about natural base. Natural base is essentially, there is something similar to pi that you use with logarithms and exponentials, and it is e. E is mainly just the natural base of things. It is a number that continues on forever. Okay, it's irrational. It approaches infinity, as you can see through the definition that's here. All you have to really know about E in order to is that you need to use it to do compounding continuously, and it is second ln on your calculator. Okay, there's nothing not going to make you memorize it at all or anything. It's just if you go second and then down where it says log, underneath log, there's a little ln. So second ln is where e to the x is on your calculator. You need that because in order to compound continuously, they use it in the formula, which is I call it APERT. It's A is equal to P to the ERT. Some of you may have seen this before. This also might be new, but compounding continuously will always yield the highest amount of money earned. And that's usually what occurs whenever you put money into some type of fund. At least if you do put money into some type of fund, you want to make sure that everything is compounding continuously. APERT is what we're going to use for example number 4. And I will go ahead and I'll write that formula up here for you. So A is equal to P to the ERT. So this is the same exact problem that we did, but now it's asking us to compound continuously. So we're going to use the A-PERT formula. Our P is still 500. Our T is still 8 years. Our R is still 0.07. But now, since it's compounded continuously, we don't have to worry about all the 1 plus R over N stuff. It's just automatically E will help us get the most out of our funds. So A is equal to 500 times E to the 0.07 times 8. So once again, if I'm doing this in my calculator, you can either write it all out at one time. A lot of you will probably be able to do that. If you're using one of the smaller, scientific calculators, I would do second ln, so you have the E up there, and then 0.07 times 8 as your exponent, and then I would hit enter and then multiply by 500. Now, it's not going to give us a whole lot of extra money compared to what we have seen before, but it'll just be the tiniest bit more. 875.34. Remember, a penny saved is a penny earned. I mean, 10 cents here and there, it adds up. Especially some of you that'll be driving soon. It's nice to have a little extra cash in your wallet for like gas money or Sheets runs. So, but this is compounding. This is part 1 of our lesson. Does anyone have any questions before we move on to part 2, which is solving? Okay. So solving is taking a step back into basic exponential equations. This is how we're going to rewrite them. So there is a way to actually set equations equal and find out what a variable would be that we don't know. One of the biggest things that I'm going to tell you is in all of these, you're going to have to make it so they have equivalent bases, because once you have an equivalent base, which I'll show you what that means here in a second, you'll be able to cross out the bases and then set the exponents equal. So let me show you example 5, and then after that, there's a couple other small variations that you'll see, but for the most part, they're all pretty much the same. So in solving, solve 5 to the 3x is equal to 125. So the first thing that you want to look at is the 5 and the 125. 5 is the smallest possible number that you can pretty much get in terms of exponentials, like 5 to the something power will give you something else. 125 is not, though. Can anybody tell me 5 to the what power would give you 125? 3. Okay. So we're going to change that to make this 5 to the 3x is equal to 5 to the third. So this is what I'm talking about when I say equivalent bases. They now have the base of 5. Because of this, in the laws of exponents, which you'll learn a little bit later with logarithms, we can actually cancel out the 5s, and then this will become 3x is equal to 3. So x is equal to 1. So essentially, once you're able to get the same base, like the same exact base, then you can cancel them out and the exponents become equal to each other. Questions? Okay. So moving through that and kind of now having that understanding, we're going to take a look at example number 6 that looks just a little bit more difficult. Just a little bit. But if you notice, 3, 3, 3, all the bases are the same, which is great. If we didn't have a same base, then we'd have to do a little bit of work like we did in example 5. What we need to know here is when we have two bases are the same, do we add the exponents or do we multiply the exponents? So let me show you. Like if this was 3 to the first times 3 to the second, we would get 3 to the third. We'd add the exponents. So since these are all the same base, I'm going to cancel them out. I'll have negative 2x plus 1 plus negative 2x minus 3 equals negative x. Okay, so now it's incorporating some of the laws of exponents. From here, we can solve. This is going to create negative 4x minus 2 equals negative x. Or 3x equals negative 2, and x is equal to negative 2/3. Okay. So at first we learned, in example 5, we learned that the bases had to be the same. In example 6, we took that knowledge and also some of the knowledge of the laws of exponents. If they're the same base and multiplied, then you add them. Same base, dividing, you subtract. You're going to see negative exponents in some of these, and then you'll also see some radicals that need changed into fractions as well. So let's move to example number 7. I'm going to show you this one. It's from your worksheet that I'm actually going to give you here in class in a few minutes. Solving basic exponents. So we've got 36 over 25 to the x is equal to 125 and 216. Nothing is in a simplified form. So think to yourself, what did 36 and 25 have in common? 6 and 5. So really, on this side, you're looking at having 6 over 5 to the 2x. And then anyone know 125 and 216? Yeah. 5 and 6 cubed. So this is really 5 over 6 cubed. The only difference then from these is that one is 6/5 and the other one is 5/6. So in order to, we're going to swap, we're going to rearrange. So I'm going to show you, this is going to be 6/5 to 2x. This is going to be 6/5. And what happens to this exponent? It becomes negative 3. Okay? Because we just flip-flopped. Now it becomes a negative exponent. So now our bases are the same. And we'll have 2x is equal to negative 3, and x is equal to negative 3 over 2.